Alright, first I'm just going to make an example of an adjacent angle. Now you already have some definitions from your teacher, so I'm not going to rewrite the definitions. I'm just going to show you some examples of some different angles so that you can just see what they look like and what they don't look like. And so over here on the left, I'm going to go ahead and write an example, adjacent angles example. And if I wanted to draw one, so let me make a couple angles real quick. So let's say we had one here and it looked like this. Now I want you to notice that when I drew this angle, that I had a common vertice. In other words, this point right here is a vertice. We'll call it A. Then I had an angle. And when I say an angle, right, imagine that this arm, right, this line was parallel or this. And I say parallel. Let's say it was on top of it, light on top of it. And then what happened was I just moved it up. And we'll call this angle right here angle A. And then we'll call this angle right here angle B. So the angles are in red. A happens to be over here. Or you know, maybe I should call this another one. We'll call this B. We'll say this vertice is B. And let's say this is angle A and angle C. I'm going to use different letters so there's no confusion. So if this is a vertice that they share in common. And then what I have here is I have angle A. That's this first angle. And then angle C, I have the second angle. So a lot of times in math, we'll mark these angles. If they're different, we'll put a line through one and have a second line through another, just showing that they're different angles. So I'm probably going to just mark it that way from now on instead of calling it a letter. But when we see one like this would be an example of an adjacent angle. And the reason is because they share a common vertex and they're next to each other, right? They're next door neighbors, as one of your teachers mentioned. So just keep that in mind. It'll look like this if it is an adjacent angle. Now also, I want you to know they have no common interior points. In other words, they wouldn't have points on the interior of the angle. Now let me show you a non-example. So I'm going to put over here non-example. So this is what it doesn't look like. Alright, so let me show you a picture of one that wouldn't be considered adjacent angle. So let's say we started out the same. We have a line, and then from the same vertex we'll do another. And let's say another. But let's start it from a different point. Okay, so I want you to notice in this one we have two different vertices. We have B, and we'll call this one, this vertice, A. Now we still have two angles, and so I'm going to use those little marks I talked about. So I'm going to put two marks here and one mark here. So we have two different angles, right? They technically are beside each other, but we have different vertices. So if you had something like this and trying to trick you, right, and it said, is this an example of an adjacent angle, you would say no. Why? Because they have two different vertices. It must start from the same vertice, the two angles, and they have to be directly beside each other. We're going to look at a linear pair. So I'm going to go ahead and I'm just going to draw a line here so that we kind of separate this. So I'm going to write right here, linear pair. Now, first of all, there's a couple things that we want to note about linear pairs, but let's draw an example, right? Because your official definition says it's a pair of adjacent angles whose non-common sides are opposite rays, and they're supplementary. So I'm going to go ahead and show you what that would look like. So if I were to draw an image, and let's say right here. I drew an angle. Now, first of all, notice that I drew a straight line. I drew a straight line with my protractor on the bottom. That's a 180-degree angle. So I do want you to keep that in mind. In other words, if I were to take this and go all the way back around until it touched the other side, that would be 180 degrees. That's what a straight line is. A straight line can be defined as a 180-degree angle. But within this, right, notice I drew a line, correct? I had this line going right here. And we'll say that these are two different angles. So let's say instead of looking at it as one straight angle, 180-degree angle, let's say we looked at this as one angle. And so I'm going to put one bar through the angle. And let's say we looked at this one right here, this much larger angle, as a second one. So I'll put 2 bars there. So this is one angle, and this is a second angle. However, if you add these two angles up, if you say this angle plus this angle, the whole thing equals 180 degrees. So this right here would be considered a linear pair because it's two angles that form a line. And what I would say is, let's call this angle 1, and we'll call this one angle 2. If I do the measure of angle 1, if I take this section you see inside of here, and I were to add it to measure 2, the angle of measure of angle 2, so the measure of angle 1 in here, plus the angle of measure 2, all the angle that's in here, it would be equal to a straight angle, which is 180 degrees. And so I'm going to highlight this too just to show you what I'm talking about. If I take this in here, that's our angle 1. And then I were to add this to it, this angle that's right beside it, angle 2, it will equal 180 degrees. We would call this a linear pair. So basically, to make a long story short, if you put the two angles together, they make a straight line. So let's look at another type of angle. Next, we're going to go ahead, and you've already heard me use the word supplementary, so I'm just going to write it again. Supplementary angle. So there's a couple different ways that we can get those. So we have two different types of supplementary angles. We have adjacent supplementary angles and we have non-adjacent. So let me show you what I mean by that. The first example that you saw me draw, like up on top, that's a pair of what we would call adjacent supplementary angles that happen to also be a linear pair. So I'm just going to draw one of those again. So notice right this angle, if I add the two angles together, the whole thing is 180 degrees. So this is an example. And let's say that we call this angle 1 and 2 again. Supplementary angles because if you add them both together, they equal 180 degrees. So just to give you an example, let's say this one over here, let's say this angle, if I were to get it by itself, is 100 degrees. And let's say this other one over here, if I were to get it by itself, is 80 degrees. So 80 plus 180 equals 180. So hopefully, like having some numbers here kind of helps out. So I'm going to put the measure of angle 1 plus the measure of angle 2 equals 180. And the reason why, well, the measure of angle 1 is 80 degrees, and the measure of angle 2 is 100 degrees. Now, of course, I didn't draw these very accurate, right? I didn't measure this to see if it's actually 80 degrees. I just want to show you what I mean by that. So angle 1 is 80 degrees. Angle 2 is 100 degrees. Angle 2 is 100. And if you add that together, it equals 180. So these are supplementary. Now, not only are they supplementary, but these are adjacent. And if you're wondering, well, Mr. H, how do I know they're adjacent? Well, because they share a common vertex. Right? They're right beside each other. So we have this vertex, right? This is one angle. And now this angle has the same vertex, and it's a much larger angle, and they're right beside each other. Similar to what we had up here when we were looking at these adjacent angles. Now, we can also say that these are a linear pair because they're supplementary, right? And they're a pair of adjacent angles whose non-common sides are opposite. So I'm also going to put on here, so not only are they adjacent, but they are a linear pair. All right. Now let me show you another example. I'm gonna draw a line just to separate this. Now they don't have to be adjacent, right? They can be non-adjacent angles. So I'm gonna show you. I'm gonna draw two angles. So let's say we had one right here, and I'm gonna put some numbers in them, right? And so let's say this one. Let's say they were separate. Let's say that this right here was a 60-degree angle. So this is a 60-degree angle. So if we have, and we'll call this angle 4. So I'm going to put number 4. So angle number 4. And let's say that we had a second angle to go with it. So I'm going to draw one more. And except for this time, I'm going to draw an angle that's 120 degrees. Again, I'm not measuring this, right? This is just a rough sketch to kind of show you what's happening. So let's say we had a second angle here. We'll call it angle number 5. And let's say this one was 120 degrees. Then we could say that these are non-adjacent, supplementary angles. And the reason why? Well, because if we take the measure of angle 4 and we add it to the measure of angle 5, they'll be equal to 180 degrees. How do I know this? Okay, well, because I gave you numbers. I said, let's imagine that this is a 60-degree angle, and let's imagine this is a 120-degree angle. You would have 60 degrees plus measure of angle 5, which is 120 degrees. And if you put that in a calculator, it's going to be equal to 180 degrees. So those two angles, if we combine them, right, they would be 180 degrees. So therefore, if we combine those two angles, they'll be supplementary, but they are non-adjacent. They do not share a common vertex. Now we just got a couple more things to talk about. The next one that I want to talk about is I want to talk about what we call a complementary angle, because you've seen supplementary angle, right? And the supplementary angle was equal to 180 degrees. But we also have to have something called complementary angles. Now when we have a complementary angle, I'm going to go ahead and just draw an angle real quick. So let's draw one right there. And let's go ahead and draw it this way. And then I'm going to put a little box in here. Now this little box, by the way, anytime you see a little square box inside of an angle like that, what that really means is that it's just a 90-degree angle. And we'll call this angle 1. So if you see a box like this, just know that's telling you it's a 90-degree angle. And this is going to be important for us to understand what a complementary angle is. Because a complementary angle is just two angles whose measures add up to 90 degrees. So I'm going to go ahead and I'm going to draw a line that goes through here. It don't really matter what angle I choose as long as it's within this 90-degree angle. And that's, notice right here, here's our vertice, right? They all connect right there. And this whole thing is 90 degrees. And when I say whole thing, if I were to go from here all the way over to there, it's 90 degrees. Now, but let's say that we're going to break this up into two angles. So I'm just going to go ahead and I'm going to break this up into two angles. I'm going to use my pink pen here. I'm going to call this the whole thing, right? That whole thing would be 90 degree. So with that one, I'm going to get rid of it. I'm just going to fill it in. We know this whole thing is 90 degree, so we're not going to name it. And let's say this small angle right here, let's say I call this one angle 2. And then let's say I draw another small angle. Let's say from here to here, I call that one angle 3. So I'm just going to shade them in so you can see it. Angle 3 is the yellow angle, and angle 2 is the orange angle. So what I could say here, let's make up some random numbers. And I know I put that big 90 right there. I probably shouldn't have put that there. So let me go ahead and take that 90 off real quick. Let's get rid of that so it doesn't create any confusion. Turn this. And so what I want to do is let's just make up some numbers. Let's say that angle number 2, let's say this is a 20 degrees angle, right? And let's say angle number 3 is 70 degrees, right? And we know the whole thing, if we go all the way across, I had written the 90 on the inside, I should have wrote it on the outside. The whole thing's 90. But let's say we broke it up into two small angles. Angle 2 is 20 degrees, angle 3 is 70 degrees. But 20 plus 70 still gives us 90. So if we put the whole thing together, it's 90 degrees. So I could simply write this as the measure of angle number 2 plus the measure of angle number 3 is simply equal to 90 degrees. So the whole thing's 90. Now I could also write this as, instead of saying the measure of angle 2, I could just say 20 degrees plus what the actual measure of angle 3 is, which is 70 degrees. And I could say this is all, if you add it together, 20 plus 70 is 90 degrees. And that's what makes it complementary. So there's your picture of what it would look like. Now, one thing I would like to say is when these two angles are sharing the same vertice, right, we have a name for those. We could also call those adjacent angles. Remember, the definition of an adjacent angle is going to be that we have two angles in the same plane with a common vertex. So notice they have a common vertex, right? This is my vertex. Let's say this is vertex, we call it B. And that vertex, right, it creates a ray right here. And then we have another angle. In other words, we have one angle, right, and there's a ray. And then we have a second angle. And they're right next door to each other. So this is going to be adjacent angles. Now let's go ahead and create a pair of complementary angles that are not adjacent, right? So we can see one that looks a little bit different. So I'm going to go ahead, split this up. We do have one more angle that we're going to talk about that I'm going to draw a picture of in just a moment. Okay, so over here, let's draw a complementary angles that don't connect. So let me draw a couple different angles. So let's say I go here and there. And let's do one more that's much smaller. Okay, so here we go. And let's say we call this vertex B, we call this vertex C, and we're going to do two different angles again. First, I'm going to call this angle number 2. And let's go ahead and say that this angle right here, let's say it's 25 degrees. So I'm going to shade in my angle. So when we say angle, right, we're talking about a measure from this line to where the line stops. It's right there. And then let's go ahead and make another one, and let's say that it's angle 3. And on this one, instead of like angle 3 over here, we had 70 degrees. Let's make it much wider. And I'm actually going to use the yellow highlighter. Alright, so there's our angle. And we're going to say that this one right here is going to be, if this one's 25, right, and we're trying to get 90, then this one's got to be 65 degrees. So notice that there are different measures. And so if we wanted to, we could say right here that the measure of angle 2 plus the measure of angle 3 is equal to 90 degrees. Because if we add up 65 and 25, that's going to give us 90. So I could also write this out as simply 25 degrees, which is the measure of angle 2, plus 65 degrees, which is the measure of angle 3. If I add those two numbers together, they will give me 90 degrees. Now, unlike this one, right, where they're adjacent, these two angles are not adjacent. And so what I'm going to say right here is these are complementary, but they are non-adjacent angles that are complementary. And now let's go ahead and let's look at our final angle that we're going to talk about today. So to do that, I'm actually going to go ahead and draw a line. And I'm going to draw another line that cuts through it. And we're going to call these right here vertical angles. So when we talk about vertical angles, they're the same. They're equal to one another. We have a fancy word in math. It's called congruent. And the angles are across from each other. So just to give you an example, I'm going to highlight them. If I were to shade this area in right here, the vertical angle would be the angle on this other side, right over here. So let's call this, let's say this is angle 1 and angle 2. So we could say the measure of angle 1 is equal to, or we can even use the little congruent symbol, is congruent to the measure of angle 2 by the definition of vertical angles. Now, we could also say, I'm going to get a different color highlighter, this really wide angle right here, I'm going to shade it in. Its vertical angle is on the other side here. So what we could do here is I could say this is angle 3 and angle 4. So we could say the measure of angle 3 is equal to, or congruent to, the measure of angle 4. Because these are vertical angles. So 3 and 4 are vertical angles. And angle 1 and angle 2 are vertical angles. They are congruent with one another. So now you know everything that you need to know about the angles to be able to answer the questions that you have from your teacher.